Alright, good day everyone. So welcome back to my YouTube channel. This is Kasaligan Vlogs. Today we'll be talking about measures of variability or dispersion, and this subject is mathematics in the modern world. So, measures of dispersion. It indicates the extent to which individual items in a series are scattered about an average. It is used to determine the extent of scatter so that steps may be taken to control the existing variation. It is also used as a measure of reliability of average value. There are four measures of dispersions that we're going to talk today, which is the range, which are the range, average deviation, standard deviation, and variance. So let us have the situation one so that we could be able to connect the use of standard deviation from the mean to the standard deviation. So measure of central tendency, which is the mean, to the measure of dispersion. What's the use of measure of dispersion in this case? Okay, so let's have situation one. Okay, so a testing lab wishes to test two experimental brands of outer paint to see how long each will last before fading. The testing lab makes 6 gallons of each paint to test. Since different chemicals and agents are added to each group and only 6 cans are involved, these two groups constitute two small samples. The results in months are shown. Find the mean of each group. So we have here two brands of here experimental brands of outer paint. Okay, we have brand A and brand B. The question is we have to find the mean of each group. So to find for the mean, we have here the formula, which is the mean. Okay. X mean for A is equal to the summation of X, the summation of X over N. So we have here summation, we have 10 plus 60 plus 50 plus 30 plus 40 plus 20. The previous topic is we have to add all of X. We have 210 over, we have the number, we have 6. So we have 35 months. So mean for the B, which is summation of X over N, which is 210, 35, 45, 30. You add this one, 210 over 6. We have still 35 months. So in this case, we could or we might conclude that both brands of the paint last equally because they have the same mean. In this time, the measure of variability would comes in this time. So to check who is more consistent about the brands or the result of this in terms of months, we have to test the variability or how spread the data is. So in this case, this measure of dispersions would be applied. Okay, so let us look at in this graph. So we could say that in terms or with respect to the mean, which is 35, we could say that brand A is more variable than brand B, or shall we say brand B is less variable than brand A. So if we're going to look at in terms of with respect to its mean 35, so we could say that brand B is more consistent to brand A because the data are spread, okay, or are more dispersed compared to brand B. So this is the use of measure of dispersion. So we could be easily to check which of the two brands are more consistent or less or more variable in terms of the data sets provided. So, in interpretation, since the means are equal, one might conclude that both brands of paint last equally well. However, when the data sets are examined graphically, a somewhat different conclusions might be drawn. Even though the means are the same for both brands, the spread or variation is quite different. The data shows that brand B performs more consistently, it is less variable. For the spread or variability of a dataset, There are four measures of dispersions that are commonly used, which are the range, average deviation, variance, and standard deviation. Okay, so the first measure of dispersion that we're going to talk today, which is the range. Range is the highest value minus the lowest value. The symbol R is used for the range. Range is equal to the highest value minus the lowest value. So let us have example. Find the ranges of paints in the previous example. So the range for A is the highest value minus the lowest value. Okay, so we have here, we have 60 minus 10, we have 50 months. Okay, the range. And for the range for B, we have highest value minus the lowest value, which is 45 minus 25, which is 20 months. We could say that in terms of the data sets in the brand A and brand B, we could say that more variable is brand B, brand A rather, because the range is 50 compared to brand B, which is 20 only. So less variable or more closer or more consistent, it's more consistent on brand B compared to brand A. So we have here the interpretation. The range for brand A shows that 50 months separate the largest data value from the smallest data value for brand B. 20 months separate the largest value from the smallest value data value, which is less than one half of brand A's range. So we could say that more variable is brand A compared to brand B. So the second, or I have here try this. The salaries for the staff of XYZ Manufacturing Incorporated are shown here. So try this one at home, find the range. Okay, try lang. Okay. So, and you have to comment your answers below. What is your range? Okay. So the next one, measure of dispersion is the average deviations or the mean deviation. It is the sum of all absolute deviation of arithmetic mean divided by the number of cases. It is summary statistic of statistical dispersion or variability. So we have here AD. Again, I want to correct this. This is absolute before we'll proceed anything else. So this is absolute, where AD is the average deviation and X is the value of any particular observations or measurement. X mean is the sample mean, and N is the population, and N is sample population. Sample population. Okay, so how to do the average deviation? There are steps. First is compute the mean of the data set, subtract the mean from each of the data value in the data set, and get the absolute values of x minus the mean, then get the sum, and divide this, and I will just correct this. This is absolute to n, which is the number of data in the data set. Okay, so problem number one, since we have here previous example, we have to compute the average deviations of the mean. So again, let's follow compute the mean of the data set, subtract the mean. So these are the steps to be followed, and which is has a less result, or the result of brand A and brand B. If the average deviation is lesser compared to the other one, we could say that that brand is less variable or more consistent, performs consistently than any of that brand. Okay, so let's have the solution. The first is we have to find for the mean, compute for the mean. Since the mean here is 35 for brand A, and for brand B also, we have the mean is 35. So next step is we have to subtract from each of the value in the data set. Okay, we have to copy. So the data here is x, and this is x minus the mean. So the data is 10, 60, 50, 30, 40, and 20. We are going to write also the data here, which is 35, 45, 30, 35, 40, and 25. The second step is we're going to subtract the data from the mean. So we have here subtract 10 minus 35, which is negative 25. This is 60 minus 35, we have 25. 50 minus 35, we have 15. And 30 minus 35, we have negative 5. And we have 40 minus 35, we have 5. And we have 20 minus 35, we have negative 15. So we're going to take the sum of this one, 210, and the sum of this one is equal to, okay, 0. Okay. Also this, we have to find for the mean. Okay, x minus the bar, mean. We have 35. Let's finish first this one. So x minus the mean, then take the absolute. Okay. So absolute of this one is 25, 25, 15, 5, 5, and 15. So the absolute of this one, x minus the mean, is, if we're going to take the sum of this one, we have 90. Okay. So after that one, we have to apply the formula AD is equal to summation of x minus the mean, absolute over n. So we have here 90 over n is 6. So we have 15. 15 is the AD. Okay, AD is 15. We have there the next, which is brand B. We have to subtract it. Okay, let's have first. Okay, 35 minus 35, we have 0. This is 10. This is negative 5, 0, 5, and negative 10. The summation of this one is 210. And the summation of other x minus the mean, have to correct. X minus the mean is equal to 0. Then after that one, we have to take the absolute. Okay, absolute of this one, x minus the mean. Take the absolute, we have 0, 10, 5, 0, 5, and 10. And get the sum. And get the sum of this one, we have 250. Okay, so we have here 250. Our AD is equal to summation of x minus the mean over Rn, which is 250. Okay. Oh no, we have here not 250, we have 10, 530 rather, 30. Okay, 30, so 30 divided by, sorry, correct, 30, 30 divided by n, which is 6, which is 5. So we could say that the average deviation of B is smaller than A, so which means that B performs consistently in terms of the the second measure of dispersion test, which is the average deviation, that the AD of 5, the AD of 5 for B and the AD 5 for 15. So we can say that B performs consistently, or B is less variable compared to A in terms of average deviation. Again, this is 30 and this is 30. Okay, 30. Okay, that's how to compute for the average deviation. Let's have the third one, which is the standard deviation. The standard deviation is the square root of the variance. It is similar to an average deviation, where it is affected by a small individual observation in the set. So we have here the formula for the standard deviation. Okay, this one. And this is the alternative way in finding the standard deviation. So where S is sample standard deviation, the value of any particular observations or measurements. If S is equal to the square root of summation of x minus the mu squared over n. So this is what we call as population. So that is how to solve for the population, and this is now this is the symbol for population standard deviation. Okay, so the change is only n minus 1, and this is for population x minus the mu squared over n. This is how to find. Also with this one, we have to substitute with this one as our n. Okay, if we're going to take for the standard deviation for population, but it's more likely we are going to solve for the sample. Okay, so steps: compute the mean of the data set, subtract the mean from each of the value of the data set, and square x minus the mean, then get the sum and substitute the formula. And here's the alternative solution. We just get the sum of the data set and square the values in the data set and get the sum and substitute to the formula. So let's start with problem 1 again. So we have here the previous example. We have to find for, again, this is standard deviation. I just want to correct standard deviation, which is the pains of the previous example. Okay, we're done with the average deviation, and now we'll proceed for the standard deviation. So the steps in the standard deviation, first is same as we're going to look. We are going to put all the data here. We have 10, 60, 50, 30, 40, and 20. And still the mean for this one is 35. And for brand A, and this is for brand B, so X here is 35, 45, 30, 35, 40, and 25. So get the sum of this one. We have 210, and the sum of this one is 210. So next step is we're going to take x minus the mean and x minus the mean. If we're going to look at for the average deviation, for the solution for average deviation, still the same process, x minus the mean. So we're just going to copy here the result. Okay, so the result of this one is negative 25. We have 25, 50, negative 5, 5, and negative 15. And take the summation of this one, x minus the mean is equal to 0. Next, we have square of this one. So this is the difference for the average deviation. This is absolute, and this one is the square. So if you're going to take the square of 25, we have 6 to 5. We have 6 to 5, and 2 to 5, 25, 25, and 2 to 5. If we're going to add this one and get the sum, the result of this one is 1750. So the formula for the standard deviation is this. S is equal to the square root of the summation of x minus the mean squared over n minus 1. Okay, so we're just going to fill in here 1750 over n minus 1 is 6 minus 1. We have the square root of 1750 over 5. The result of this one, if you're going to take the calculator, we have 18.71. Okay, so this is the standard deviation for brand A. And next, we're going to compute for the standard deviation for brand B. Still, we have to copy for the result of x minus the mean in this case. So we have here, if we're going to copy, just look at your previous a result for this one, x minus the mean. Still, the mean of this part is 35. Okay, so we have here x minus the mean, we have 0, we have 10, we have 5, we have 0, 5, and 10. Okay, by the way, it's negative 5, and this is negative 10. So summation of x minus the mean, no, this is not absolute by the way. Ganyan lang. X minus the mean, not the absolute, is equal to 0. Summation of x minus the mean is equal to 0. The next is we're going to square of this one. So we have 0, 100, 25, 0, 25, and 100. So summation of x minus the mean squared. If we're going to add this one, we have 250. So applying the formula, s is equal to the square root of this one. And this is the formula. So we are going to have the summation of x squared. We have 250 over n minus 1 is 6 minus 1. So the square root of 250 divided by 5, that is equal to 50. Or the square root of this one is 7.07. So we could say that the standard deviation for B is lesser than A, so it means that B performs consistently and it is less variable compared to A. So meaning to say A is more variable or more dispersed compared to B. So in this case, even though we have the same mean, but we could compute the standard deviation and we could conclude another way that B performs consistently than A, and B is less variable than A in terms of the data given. Okay, so the alternative solution in finding we have here first is this is the formula for alternative solution for standard deviation. The formula is this one. S is equal to the square root of summation of x squared minus summation of x then squared over n minus 1. So this is the formula. So first is we're going to find for the data for this one is 10, 60, 50, 30, 40, and 20. And first we're going to get the sum of x because it's needed here. We have 210. Next is x squared. Take the x squared. We have 100, 3,600, 2,500, 900, 1,600, and 400. So summation of x squared, which is 9,100. And we're going to compute for this part. So summation of x squared, which is 9,100 minus, we are going to have 210 squared over 6 over, okay, 6 minus 1. The square root of this one is 9,100 minus, which is 210. They have 4,100 over 6 over 5. Okay, so the square root of this one, we have the square root is 9,100. This is 44,100 divided by 6 is minus 7,350 divided by 5. So our S now is the square root of 1,750 over 5. So what's the mean now? What's the standard deviation here? The standard deviation is equal to 18.71. Okay, so the standard deviation is 18.71. Same with the result of the previous example or the previous formula. Next, we have x here is 35. This is a given. 45, 30, 35, 40, and 25. And x squared here is 1225, 20,025. Okay, so we have here 35 squared. We have 1, 2, 2, 5. We have 40 squared. We have 1,600. And we have 625. So summation of x here is 210. And summation of x squared here is 9,000. No, the summation of x squared here is 7,600. Okay, 7,600. Okay, if we're going to take the sum of this part. Okay, if I'm applying the formula, S is equal to the square root of, okay, the square root of summation of x squared, which is 200, 7,600 minus summation of x is 210 squared over n, which is 6 over 6 minus 1. So our S standard deviation per B is the square root of 7,600 minus 210 squared, which is 44,100 divided by 6 over 5. So our standard deviation for B is the square root of, we have 7,600 minus 7,300 divided by this part, 44,100 divided by 6, we have 350, and this is overall 5. S B is equal to the square root of 250 over 5. SB is equal to, if we're going to compute, we have 7.07. So we could say that the standard deviation of B is lesser than the standard deviation of A, which means that, again, B is B performs consistently or less variable than A compared to A. So our A is more variable or more scattered or dispersed compared than brand B. So again, this is the alternative solution for the standard deviation. We have here the next or the last part, which is the variance. The variance is the average of squares of the distance each value is from the mean. Individual differences from the different persons are one of the most common sources of variance. For instance, when the scores of different persons in the same examination differ from each other, there is a variance. But when the scores of individuals are identical in each item, there is no possible basis for individual differences. In such example, hence there is no variance. Okay, if this identical, there is no variance. So how to take the variance of this one? If the result for the last part, if the standard deviation of A, okay, if the standard deviation of A is equal to the square root of 1,750 over 5, if we're going to take the variance of this one, we are just going to square, okay, to square here. So the variance of this one, 170 is over 5, is 350, then square, we have 315. And the variance for A and the variance for B is, if we're going to compute the variance for B, is we have here, the last portion here is 250 over 5, the square root of 250 over 5. So if we're going to square this, so this would become 250 divided by 5, that is equal to 50. So therefore the variance for B is 50. So we could say that the lesser variance is less variable compared to the bigger variance. or we can say that variance for B is more consistent, performs consistently, because B has a smaller variance compared to A. Again, the formula for the standard population or the variance population is this one. Okay, then we have here the summation of x minus the mu squared over n. So this is the formula in finding for the population for variance. Okay, that's it for the variance. Again, there are four measures of dispersion: the range, average deviation, standard deviation, and the variance. A simple way for variance is the square of the standard deviation, or the standard deviation is the square root of the variance. So we have here, try this at home. There are three data sets have the same mean and range, but is the variation the same? Prove your answer by computing the average deviation and standard deviation. Assume the data were obtained from samples. So 5, 7, 9, 11, 13, 15, 17, 5, 6, 7, 9, 11, 15, 16, 17, and 5, 5, 5, 11, 17, 17, 17, and 17. So thank you for so much for listening for this Kasaligan vlogs, and I hope everyone you learned something today about measures of dispersions, the range, average deviation, standard deviation, and the variance. Thank you, and please comment your answer below in my YouTube channel, which is more variable, or but is the variance, this is the variation the same in all A, B, and C, and try to compute for average deviation and standard deviation. Thank you, and God bless.